Hello, everyone. My name is Fernando Marin. I'm CTO with Ofcdesk, and today I'm going to present to you a use case study, which is about power substation designs using Revit, APS, and AEC Data Model. So to get started, here's our agenda for this presentation. So it's going to be a brief introduction about the topic. Then we will talk about Eletrobras, which is the partner company. We provide the implementation of this solution. Then we will explore a little bit about power substation designs in Revit and the challenges this can bring to companies. Then we will explore how can we leverage the BIM model using, of course, Autodesk Construction Cloud, ACC, and APS, Autodesk Platform Services. We are going to get deeper into APS a little bit, exploring AEC Data Model and data exchange. And at the end, we are going to talk about potential next steps. So starting with the introduction about this topic, that today worldwide, the greatest challenge is to generate power, electricity, distribute that in a way it can accommodate all the new technologies coming up. So this is a very challenging process because you have not only to generate the power from different power sources. So we have hydroelectrical power generation, wind, solar panels, and all sort of sources. But you need to pack that power and transmit that and deploy it to cities and industries and other areas that will consume that. So this itself presents a great challenge in the process today. We are connecting that challenge to how we can address that using BIM and solutions that could leverage the process itself, not only for creating these designs, but also to operate these complex infrastructure facilities. And we can start by showing you guys a little bit about the power grid and how it works. So here we have what we call the power sources. It can be, again, different types of sources. You generate power and you need to transmit that power to whatever area is going to consume that. So that represents a challenge that needs to pass through a power substation that is going to step up the voltage and then use transmission lines to deploy this energy across different regions. And once these regions receive that power, they need to do a step down of the voltage so they can distribute to residences, commercial facilities, industries, and everything else. So the power substation plays a really important role in this process because it's responsible for connecting the generation and the consumption of energy. And you can see here on the right side, we have really good trends about how substation is going to play out in the market. You can see the numbers growing a lot since last year, passing through this year, and what's expected for the next years. And that, of course, is going to put a huge challenge on governments, on the technical companies, engineers, staff that will need to, accommodate all these requirements into their daily tasks, right? Because we are expanding the grid, but we need to keep whatever we have today working, operating. And you can see here down some potential demand growth throughout the next years. So you can see it's a very demanding. And this, of course, together with everything else, puts a great challenge to the overall worldwide demand right now. If you include AI to the process, AI is very power hungry. So it will require lots of data centers to be created, included. And this, of course, will put even more challenge and demands to the power substations. So here just 4 examples of these facilities. You can see they're very large and they're very complex. They comprehend lots of different equipment. In these, regardless if a step up or step down substation, it deals with a high voltage, right? So these presents challenge for work safety. They need to have lots of protection equipments. The process is complex. And you can see the disruption of these power substations can cause, many other issues in cities and hospitals and facilities that need to keep working uh, all the time, right? So it's a very complex infrastructure designs. Uh, so to address that and to help addressing that, we create a bunch of solutions to create a system that would facilitate the process. This investment from Eletrobras is a much broader investment that comprehends not only addressing existing substations, so they need to digitize them using point clouds and then create a BIM model called counterpart or the digital twin, but also they need to have tools for creating new designs. So if you remember, I just presented you guys the demand growth. So they need to equip their design teams to use more tools to facilitate the process. So this is why we created a plugin in Revit to leverage the process. And of course, this can even go further, submitting projects to ACC and use APS infrastructure to connect those projects to other systems. And at the end, these substations, this is the ultimate goal of Eletrobras, is to use Autodesk Tandem to operate those facilities after they're built. So let's talk a little bit more about the Eletrobras company. This is the company from Brazil. They are a leader in power generation in Brazil, and they have in their portfolio about 96.5% of low emission power generation facilities. If you know, Brazil is very known by their great hydroelectric power. So we have lots of rivers and we can generate a lot of power from these natural resources, right? So Eletrobras, they have more than 100 plants and they generate 44.2 gigawatts of energy that represents about 21% of national capacity of Brazil, right? To distribute that huge amount of energy, they have 74,000 kilometers of transmission lines, and that again accounts for about 37% of national grid. So it's a huge. Just to provide you guys some size comparison, this is a very interesting tool that you can use the actual size of countries. So if you compare Brazil to United States, Canada, Africa, Australia, China, even Middle East, and Russia as well, and finally Europe, you can have a reference to the size of Brazil territory. And if you go deeper, this is a chart of all the power grid of Brazil. You can see how extensive it is. And you can note here we have some black dots to represent substations and those black triangles to represent hydraulic generation. As I mentioned, we have lots of rivers in Brazil and we have lots of dams. Those dams generate a huge amount of power that needs to be distributed throughout the grid. And you can see here, this is the central region of São Paulo. It's more demanding in terms of industrial requirements, lots of industries, lots of power consumption. So we have São Paulo, Rio de Janeiro, and Minas Gerais. Those three are the main three cities and states of Brazil. And you can see here we have lots of power substations to address, distribute, step up, and step down this energy process. So here's a map of Eletrobras infrastructure in Brazil. So you can see those diamonds, they represent wind generation facilities. The blue squares, they're thermal generation. And the green triangles, they're hydroelectric. We have a few solar. It's still growing in Brazil, but most of the power we have today, it's coming from hydroelectric power generation. So moving to the details about how this can be done using Revit, we started, of course, analyzing the complexity of those models. As you can see here in this small example, we have lots of electrical components in a substation design. So that comprehends transformer, electrical cabling, keys, isolators, and all these things. They have manufacturers that create those products. And those products needs to be modeled and included in the BIM design. So you can, thinking about what I said before, if you plan to operate those facilities using Tandem, you need to think about that goal since the beginning of the process, right? So here we also embedding engineering tools inside this plugin because it looks simple, but all this cabling, they need to pass through intense calculation process to determine the appropriate curvature of those cables because they need to have clearance from other equipment. Remember, we are talking about high voltage, so it creates a huge electromagnetic field around those cables and those equipments. So it's a very delicate process to design these substations. Here, just as a further explanation, this is a transformer. When we model, and our team did modeling for all those equipments, we need to take into account also the LOD, the level of detail, because as these are huge models, it's complex for the designer to see all details, and they need to keep switching from different LODs to be able to travel throughout this 3D model and still see the details. There's here a list of some parameters example. They're bound to this BIM model, but the goal is to have inside Revit just the amount of information that's necessary for design, meaning outside Revit, and we are going to show that in a bit. We can connect information from the design scope to the operation scope that will comprehend information about equipment, operation, parameters like temperature, voltage variations, and everything that's necessary to control these substations when they're operating. So here's just a brief example of this plugin running. So we're going to show here how to create a cable. So in this example, you're seeing these horizontal structures. They are called bus bars. So they will do the connection process to, again, if you step up power substation, you're going to move the voltage up. If I step down, it's the opposite. So we have appropriate components to do that. And everything needs to be isolated, right? So think about all these structures. They're subject to storms, lighting, discharge. So it's a very complex design process. So here, just another example. If you're passing a cable through these isolators, you need to have the perfect curvature drawn. And it can be as complex as a single cable. You can have a double cable in this example. So it needs to have appropriate connectors in their ends. If you have some, keys here, you also have to pass those through cables through the process. And here is the example of 4 cables. So this is a very complex. Can you imagine how complex it is to design that manually in Revit to do the appropriate curvature of those things? Because again, it's very important to have a precise 3D model. The goal is to do analysis like, okay, if a transformer explodes, what is the consequences of that explosion, right? And for that, we need to have a precise model to determine the areas that are going to be affected and everything else. So moving to the next one. Another aspect of this, as I mentioned, is to bring engineering calculation. So we have this thing that we call catenary design. So essentially you have the span, the distance, you consider the cable type, cable diameter, temperature variations, and all those things, they are considered to design a perfect curvature. And as you can see in this input information, you define the number of cables, temperature that is going to be predicted in this portion, the voltage that also impacts on the design. If it's a long span, you need to put spacers so the cables does not touch each other, right? That would cause problems. And at the end points, you need to define the type of connector for this cable span, right? After you do that, so you select the start point in one bus bar. So you're going to pick precisely that point that was created in the bus bar equipment families. And then we select the other end. And then there's going to be a bunch of calculation behind the scenes in the plugin. So it can calculate again the span and design the perfect points of this curvature. What the plugin does, it traces the cable passing through every single point calculated. So we have the perfect curvature of this cable. And again, this is very important to see if it's going to be too close to other electrical equipment. That would be a violation and a risk. So they need to have this precise design. And thinking about existing substations, they need to scan a point cloud, but they need to trace those cables in a real-time scenario, so they can see if the situation today it's matching what is expected on the design process. And you can see here how many points they're traced. You can see also the spacers, and it's a long span, right? And you can, again, see how complex that would be if you need to do it manually, okay? So moving to the next one. So this is an example of disconnect isolator modeling. So let's see, this is another example. So in this case, we have again the bus bar, and we have these switchers. So they're responsible to cut the power flow if it's necessary. It could be for maintenance reasons. It could be for a problem that needs to be solved. So the way it works, you select the cable, number of cables again, the distance between the cables, the spacers, and then you select one point, another point, and the third point, and we'll trace the cabling passing through those sections, and we'll trace them in 3D as well. So you've seen a bit that once I specify the connection points on both ends, again, this is based on the voltage and the infrastructure design requirements. So the 4 cables, they are designed, and if necessary, in this case, it wasn't, it creates the spacers to accommodate that. So you can easily see how complex it is to deal with these things in 3D, and Revit does a great job dealing with those elements in all their required level of details. And you can see that you can repeat the process to the other busbar elements. And with that, the design process, it's much faster, and it's way more reliable because it's trusting on the engineering calculation behind the scenes and throughout these commands. So again, a side view of the process. You can see that we have connectors in the end. So you're using Revit connection capability of families. And then you can see, how this can be easily addressed using this plugin, right? So we talked about how to do that in Revit using this plugin, but how can we leverage that? How can we use ACC, Autodesk Construction Cloud, and APS to leverage that? Let's have some aspects that we need to take into account. Again, 3D modeling, it's the first step. So we need to model those elements, those equipments, those cables with a geometric precision. So we have accuracy in how they interact in the 3D environment. LOD, again, level of detail, is necessary for complex designs, huge substations. They're very heavy. They generate a big Revit file. Legacy modeling, again, they need to analyze, and they're doing that, all the legacy substations. They have substations 20, 30 years old, so the equipment's changed. So they need to accommodate that into the BIM modeling process as well. And of course, support for the new equipment. So the industry, the electrical industry in general, they of course are evolving. So they're creating new type of equipments. Sometimes they reduce the size of equipments, and all these designs, they need to take that into account. Then moving to parameters, as we mentioned, we talk to their engineers, we analyze what is necessary to put inside these families, but nothing more than that. It's not a good idea to overload the BIM model with too many information, because in their other processes, and they do inspections, they do life cycle analysis of those equipments, they have more data outside Revit, but we need to connect the BIM element in the 3D model with all counterpart information like documentation, statistics, and that is done via external links. So we need to prepare the families to have external connections with other data sources. And then at the end, the benefits of doing that, they come from data science and go down to BI capabilities and AI capabilities. Because if you think about, we are doing BIM modeling of existing substations and new substations, with all that information, these can be used for future design improvements, and also to help Eletrobras to learn and improve their design processes. So a little bit of ACC here. So how can ACC, Autodesk Construction Cloud, help this process? The first goal is to track all those elements in the 3D model and create assets counterpart inside the ACC. And these assets, they will leverage the ACC capabilities. So think about, we have a transformer, for example, it's modeled inside this substation, and we map to an asset inside ACC, and then we need to have to do a field inspection in that element. So the inspector uses ACC mobile app. He visits that power substation. He can get the asset, link that, and view that asset in the 3D model and see all connected information like documentation, maintenance documentation as well, history of that equipment. So, for example, did it present problems in the past, right? And also track the maintenance process as well. This is, again, is a very delicate process because you cannot simply turn off the substation, not right? It will cause lots of problems. So you need to plan those maintenance. You need to have backups taking over that power line. So that's a very complex process for doing maintenance as well. And at the end, of course, if you have all this information, you have manufacturing information, you can also track costs for those maintenance and those equipments. And when they have damage, how is the cost impact of that in the design process as well. So now let's talk a little bit about AEC Data Model and data exchange and how these tools can also help. A little bit of introduction about AEC Data Model. So it's this relative new technology in the APS platform. So it uses the GraphQL. It's a way to easily track data information and collect data information. And the goal here first is to be able to allow collection of cross-project data. So in our example, suppose Eletrobras employee wants to see, okay, I need to check in which substations we are using this particular equipment because the manufacturer did a recall, right? So instead of opening one by one, they can go and use GraphQL and AEC Data Model to do a search and go inside each Revit design through AEC Data Model and collect the technical information. So AEC Data Model is capable of going inside these models, collect information, and deploy them in organized fashion for the technical worker that's trying to collect this information. So here's just a brief example. We create this mock-up website. So I'm selecting a sample project in a sample hub in ACC. And now I'm collecting information about specific equipment across all published projects that were hosted in ACC. And as you can see here, we can grab element name, its information, some other specifications. I can create charts on the fly to do a BI analysis approach. So you can see exactly the number of equipments. I can use grouping in this capability. So think about doing this manually, go inside every single Revit project, collect information, copy this to somewhere else, and then trying to blend and analyze the information. Using AEC Data Model in GraphQL is just a way to, submit the query you want, get the results, and format the results to do further analysis. Of course, you can connect this data collection to other processes. So you can trigger, for example, issues inside ACC. You can generate communications. You can send SMS messages to, workers connected to those substation facilities. Again, once you collect the data, you can do a lot of things. And we mentioned AI, for example. AI would be a good, client of this data repository, because with that, we can also start creating prediction algorithm and help, to anticipate potential problems in these substations. Okay, keep in mind again, this is a very delicate infrastructure elements, and the disruption of, a power source can cause, unimaginable problems in cities and other industries and everything connected to the grid. Okay. So now let's talk a little bit more about APS data exchange. So we talk about how to collect data using AEC Data Model in GraphQL. But we can also use data exchange to integrate the substation design process to other subcontractors and other companies that need to access that information. Today, data exchange is offered in a bunch of default plugins that you can install in different software, but you can create your own data exchange. There's an SDK for that. We're not going into technical details today, but just to make sure you know, if you want to create, for example, inside your own software, a way to collect that information that's published in ACC and represent that locally inside your software, you can use the data exchange SDK to do that. We're going to show a little bit of examples here. So I'm inside Autodesk Construction Cloud. I published this Revit design. It's just a section. And then I'm going to create a data exchange out of that model, right? So in this example, I'm creating a data exchange here in this view, right? And this is the data exchange we created. It's going to be a subsection of the whole 3D model. And again, it can bring all the information that's coming from the BIM model. And again, that's the information. And that's why it's important to put everything in the BIM model that's relevant to that. After I create this exchange, I can work with filters and see all the necessary information. Once I have these exchanges, I can also use this data exchange model explorer and get information about that exchange model. So here I'm doing first step to collect the hubs. Then I'm going to collect the projects. In this case, going to return this DevCon 2025 project. I collect this project ID. Then I can collect the project folder. So I need to go inside the folder where that data exchange was saved. So I'm going inside the project file folders. Then I'm going to collect the content of that folder. So it's going to list everything that's inside there. So you can see there's two subfolders. I'm interested on this particular one. So I get its ID. And I use that to the next step, which is going to collect the information on that folder. And then I go to the next one, get its ID, repeat the process, and go inside that folder. And then I'm going to reach my goal, which is to get this exchange. So you can see the type name is exchange. I have two. I'm interested in the circuit one. So I get its ID. And then I'm going to get the information about that exchange, right? So if I run the process again, it's going to return me the ID and the file URL of that exchange. If I use that viewer tool up there and paste that exchange, it will then collect the graphical design of that exchange that I shared. So you can see how this can be used for numerous purposes, right? So if I want to share the information just about that particular equipment in my substation, I can create the exchange of that particular element. I can share that, and whoever is connected to this project in ACC can read that information and represent that exchange inside their design software, right? So these high-end industries, it's a pretty common, they have customized software. So data exchange will help them to bring that information inside. And as you can see here, once I collect and go inside the data exchange, I can collect information of all models represented there and, do anything with that information after that, right? So let's talk a little bit about AI. So we talked about designing this substation in Revit, publish it to ACC, and have the data available. So what we can do with that information. So first one, of course, if we have numerous substation designs, we can create AI algorithm and models to collect this information and provide me insights of future designs and everything else. So think about all these substations they're operating. There are probably good designs. They're matured throughout the years. The company is doing that. So they're good examples to work as a foundation for the new substation designs. But as I mentioned, the equipment's changed, technology changed, a little bit of the engineering calculation changed, the power demand changed. So AI can help Eletrobras using this system to improve their future design by, doing predictions, collecting information, and doing everything else. AEC Data Model helps us to collect multi-project information again, right? And of course, every single new project created with this system will have, all the information stored and available for all these things. Then we can use generative models to create design solutions from scratch. So a model can be created to, provide tools for them exploring new design solutions. AI can help with that as well. And also we can do simulations, right? Again, it's a very common, you have problems with this substation. So we have equipment failures and all these things. So we can predict failure, we can predict maintenance costs as well. But also we can do simulations to see how an explosion could affect, all elements close to that, transformer, for example, that exploded, right? Funny enough, AI itself will benefit of the improvement of this whole design process, because AI is really a power-hungry technology. You're seeing today lots of data centers and processing centers being created just for running those AI terminals and servers. So AI will benefit from this improvement itself. So a little bit of conclusion here. Again, Revit does a great job supporting this large-scale power substation design. So it's being proved to be very efficient doing that. Of course, we need to extend native functionalities of Revit through a plugin. So the plugin will bring engineering knowledge inside Revit to provide, designers a good set of tools to improve their design process in terms of speed and quality. APS, AEC Data Model, helps to do cross-project information collection. So we can, again, publish to ACC, have all these projects tracked and collect information. Even when they have reviews, sometimes you have a substation that needs to be extended. So you need to complete that design. So having the historical information about all these power substations is always going to be helpful. And the ultimate goal that we mentioned at the beginning of this presentation is to operate these substations using Autodesk Tandem. So this will provide the foundation, all the necessary data, geometric precision, and all required engineering support for operating these substations. There's going to be another section in this DevCon event that you should watch that will provide a broader perspective on this project. We are presenting here just one step, which is modeling and creating content and leverage content of these power substations. So thank you very much for watching this presentation. Hope to see you in person in the event. And I would like to also thank all the Ofcdesk team that did a great job, both modeling and creating this plugin. And thank you so much, Eletrobras, for bringing us this challenge. And all your staff is brilliant. All your engineers are great. And I hope this can be, applicable to other industries and across the world in other power facilities and power grid challenges. Thank you very much.